Hi viewers, this is Sri Ramlu. Now one more topic is what concentration of holes. So already I have uploaded the video concentration of electrons. So if you observe, if you learn that concentration of electrons, then it is very easy. But small changes will occur in between these two things. That small change, if you keep in mind, if you remember it, then you can easily solve. You can easily remember whole derivations. Okay friends, so let me enter concentration of holes in intrinsic semiconductor, holes present in valence band. Yes, okay, an intrinsic semiconductor where the holes present in valence band, electron present in conduction band, but Fermi level lies exactly in between two things. Now, the number of holes in energy range E plus dE is dP. P is called concentration of holes, and its formula is dP is equals to density of states into probability of hole. And here probability of hole, what we have to write 1 minus f of E. But there in the electron, what we have written simply f of E only written, but in hole just 1 minus. That is small difference. This difference only leads to change the final formula. dP is equals to Z of E dE. So density of state is Z of E dE into probability is 1 minus f of E. So integrating on both sides we get this one. And in integration, see here limits are changed from minus infinity to EV. Why it is minus infinity? See here. EV is the topmost energy of valency band. So it is the last one, and most of the holes are present downside only. Up to where? Up to infinity. Which infinity? Downside we take minus infinity. Upside we have taken already plus infinity. So that is why holes present here only, and here to downside. Downside up to where? Up to minus infinity. So upper limit is what? EV, and lower limit is minus infinity. So that is why minus infinity to EV is taken there into. So it is taken like this, and we know already density of states formulas like this, and f of E is this one, and substitute these two things in the above equation. Then what we get? We get this one, isn't it? Now in the place of E replaced by E minus E. So just now I said EV is the topmost energy. So then simply write it as topmost energy minus E. So EV minus E. Here substituted. It is a copy pasted like this only. Now, so take it is outside for simplification. So it is taken outside. Okay. So by simplifying it after simplification, here we have to substitute. So for this purpose only it is taken outside. It is like this. And take LCM. LCM means a whole product, this whole quantity multiplied to the 1. Then what do you get? 1, this same thing will present. Okay. This one present here. Right. If you multiply to this one, then you can get this one only. So 1 minus 1 plus 1 gets cancelled. Then what remains? This one by this will remains, this one by this remains. Okay, and bring it downside. Already it is a plus upside. If you bring it downside, it becomes minus. Okay, so one example I will show you. E power of x by 1 plus e power of x is there. That means this bracket take it as x. Okay, now bring this is a downside. Then 1 by e power of minus x it becomes when you bring it downside. 1 plus e power of x, isn't it? Multiply it now inside. So what you get? E power of minus x plus e power of minus x into e power of x. These two gets cancelled. Here what you get? Here 1 we get. So like this, see. Already I said it is a total factor is minus x. Okay, so e power of minus x plus 1. E power of minus x plus 1. Isn't it? It is like this. Now we have to apply the condition this one. At a lower temperature, so this factor is very much greater than the 1. Then exponential factor also is much greater than 1. Then 1 can be neglected. Yes, 1 by this one neglected. and bring it is see in downside only one factor is there, so bring it upside. Already it is now minus. If you bring upside it becomes plus. Why? How? E power of minus x is there. If you bring it upside, e power of plus x. So like this it is plus. Now substitute it in the equation 1, isn't it? Okay, so this value substitute in the place of this, so that is in equation 1. Here equation 1. Okay, see this is equation 1. In this equation, so this factor is substituted here. Okay, now take it is outside. See outside written and it is inside. See it is inside written and separated here also, isn't it? So e power of, see, if e is a plus, ef is a minus, ef is a minus, e is a plus. Okay, like this separated. Okay, it is separated like this. And here integration with respect to e only, so that means it is integrable, but it is a constant. Ef is constant. Bring it outside. And here total factors, these are the constant quantities also brought outside like this. Okay, and then it also comes like this. Now substitution method we have to implement here. Same thing what we have done in the previous, in the concentration of whole, same procedure we have to follow. So in the place of this, simply I have taken x and integrate it, differentiate it. So differentiation, it is constant, it is 0. Its differentiation is minus d, and x is dx, and bring it minus this side, d is equals to minus dx. Okay, limits. Limit is what here? What are the limits? Limits are minus infinity to ev. Now place substitute e in the place of e as ev. So substitute here ev in the place of e. What you get? Ev minus ev becomes 0. Okay, why? Because in the place of e, what you have to substitute? ev. So here ev, if you substitute ev, already ev is there, ev minus ev is 0. Okay, now in the place of e, now substitute minus infinity. Okay, in the place of e, substitute minus infinity. Already minus is there, minus minus plus, so infinity plus ev becomes infinity only. So plus infinity we got here, isn't it? Plus infinity. So values are changed. ev in the place of ev 0, in the place of minus infinity plus infinity. Okay, so here in the place of ev 0, in the place of minus infinity plus infinity substituted. And here, see, observe here. So in the place of minus infinity plus infinity, in the place of ev 0. Okay, in the place of this bracket x is substituted here. Yes, and one thing in the place of e. So from this what we can write e. Okay, so e is minus, bring it outside, and x is plus, bring it itself this side. So ev, sorry, not plus. Okay, bring this is e this side and x is this side, ev. So if you bring x this side, it becomes minus, x is equals to, already e is a minus, if you bring this side it becomes plus. So in the place of e, what we can substitute? ev minus x. Okay, in the place of e, so here in the place of e, ev minus x is substituted. And one thing, in the place of de, in the place of d, minus dx we have to substitute. Okay, so don't forget this is, if you forget this one, you cannot get answer. Now this is the formula. Okay, and separate this one once again, or before it, one thing before separating this ones, here minus is there. If you want to remove a minus, then change the integration limit. Now see, this infinity is upside and upside value is downside, then minus can be removed. Okay, so because of minus only, if you have suppose a to b minus dx, it can be written as b to a into dx. So if you want to remove minus, change the limit. So limits are changed. In the same manner here it is also applied. Okay, in the same manner here it is done in the same manner. Minus is removed here. Now separate this one as this one and this one. Okay, EV is a plus e power of minus x is minus x. So this, but here integration with respect to x only. Then can we take it as a constant outside? Yes, we can take. Now it is integrable, but it is a constant taken outside. It is like this written. Now bases are equals in the product, then powers what we have to do, we know that is. So powers are, so EV is positive one, EF is negative one. So written here, EV positive, EF is negative. And this is the formula, this one. Okay, this is the formula, this one. Again, in the place of this, we have one formula, what we have applied in the previous one. In the concentration of electrons only, same thing is. So KT in the place of KT, he A. So actually, X by A here. So in the place of A, what you have? KT you have. So here KT power 3 by 2 into root pi by 2 can be written. So that is a simple applied here. Okay. KT power 3 by 2, already this factor is 3 by 2. Now we can mix here. So like this 8 KT and root pi can be written as 3 pi by 2. 3 pi by 2. So here 3 pi by 2. So that is 3 pi by 2. So pi also we can include inside. So it is already copy pasted here. And next is, so here inside what we have, inside 8 pi, 8 we have. 8 can be written as 4 into 2. So keep 2 inside only and bring 4 outside. But 4 power also this come. So already I explained you 4 by 3 come outside. By 4 we have. So bring this 4 in numerator, then 4 by 4 power 3 by 2 into 4 power minus 1. Here bases are equal in the multiplication, then powers what we do, we know that is. So write 3 by 2 minus 1. So 4 power 3 by 2 minus 2 by 2 we can write. So why? Simply this is multiplied to this one. 3 minus 2 is 1. So 4 power 1 by 2. 4 power 1 by 2 is written as root 4. Root 4 is value is 2. So that is why this 2 has come like this. Okay. So this is the final formula EV. So 2 into 2 pi KT mH. mH I didn't tell you. mH is the effective mass of hole, that is the meaning. So 2 into 2 pi KT mH star by h square power 3 by 2, and this is e power of EV minus EF by KT. So this is the friends, this is the equation of concentration of hole. Okay friends, thank you. So please don't forget watching this video till the end.